Let's start right here, right where you are. You are likely sitting down watching this video. Maybe you're on a chair or couch or standing on the floor. You feel the weight of your body pressing against the surface. You feel the ground solid and stable beneath your feet. If you reach out and touch the table or the wall next to you, it feels hard. It feels undeniable. This sensation of touch is your primary connection to reality. It is how you know that you are here, and that the world is real. It tells you that space is filled with things, and that those things are solid. But this is the first lie, and it is a massive one. If we were to look at what is actually happening where your skin meets that chair, if we could zoom in past the skin cells, past the molecules, down to the level of atoms, we would see something that contradicts everything you feel. We would see that nothing is touching anything. The atoms that make up your body and the atoms that make up the chair are almost entirely empty space, 99.99999% vacuum. If you removed the empty space from every human being on Earth, the entire population would fit inside the volume of a single sugar cube. So why don't you fall through the chair? Why doesn't your hand pass through the table like a ghost? What you are interpreting as solidity is actually a force field. The electrons in your body are negatively charged. The electrons in the chair are negatively charged. And because like charges repel, they push against each other with tremendous power, long before they ever make contact. You're not sitting on the chair. You're hovering above it. You're suspended on a microscopic cushion of electromagnetic repulsion. You have never touched anything in your entire life. Not your phone, not the food you eat, not the people you love. You have only ever felt the resistance of invisible fields. The sensation of a solid world is a hallucination generated by your brain to explain why you stop moving. The reality is that there is almost no stuff there at all. Just emptiness and forces pushing against other forces in the dark. Now, you might say, okay, touch is a trick of physics, but I can see the world. My eyes don't lie. We assume that when we open our eyes, we are seeing reality as it is, in real time. A live direct feed of the universe. But this is also biologically impossible. Think about how vision actually works. Light bounces off an object, enters your eye, hits the retina, and gets converted into electrical spikes. These spikes have to travel down the optic nerve, get processed by the visual cortex, and then be reassembled into the three-dimensional model that you experience as sight. This process takes time. It is fast, but it is not instant. Neuroscience tells us that there is a delay. It takes roughly 80 to 100 milliseconds for your brain to process this data and present it to your consciousness. That might sound like a tiny fraction of a second, but in the world of physics, it is an eternity. It means that you are never living in the present. You are permanently trapped in the past. Everything you see, everything you hear, every person you speak to, you are interacting with a version of them that is already gone. If a light bulb flashes, it has already gone dark by the time you register the light. If someone snaps their fingers, the sound hits your mind after the event has ceased to exist. Your brain tries to hide this from you. It predicts the future. It edits the timeline. It synchronizes the audio and video tracks in your head, so you don't feel the lag. But the lag is there. You are watching a delayed broadcast of reality, and this raises a deeply disturbing question. If your brain is already editing the timeline, if it is already constructing a model of reality rather than showing you the raw feed, how much of that model is real? And how much of it is just a user interface designed to keep you happy? This brings us to the most uncomfortable question of all. Why would our brains do this? Why would evolution, the process that designed us, build a system that lies to us? For centuries, we assumed that our senses evolved to show us the truth. The logic seems sound. Surely an organism that sees reality accurately, the tiger in the grass, the edge of the cliff, would have a better chance of survival than one that sees a hallucination. But modern science suggests exactly the opposite. Donald Hoffman, a cognitive scientist who has spent decades modeling human perception, tested this mathematically. He used evolutionary game theory to run thousands of simulations. He pitted organisms that saw the full, complex truth of objective reality against organisms that saw a simplified, dumbed-down code designed only for fitness. The result was shocking. The organisms that saw the truth went extinct. Every single time. Why? Because truth is expensive. Reality, whatever it actually is too complicated. It is full of quantum states, high-dimensional fields, and complex equations. To survive, you don't need to know the physics of a tiger. You just need to know, run. Evolution didn't design us to be scientists. It designed us to be survivors. And to survive, the brain had to hide the truth. It had to strip away the complexity of the real world and replace it with simple, easy-to-understand icons. This means that the world you see around you, the trees, the cars, the stars, is not the world as it exists. It is a headset. It is a biological simplification that hides the true structure of reality specifically so you don't go insane trying to process it. To truly understand what this means, look at the screen of your computer or your phone right now. You see a blue icon that represents a folder. You know what that icon means. You can click it, you can drag it, you can delete it. But ask yourself, is the file inside the computer actually blue? Is it rectangular? Is it located in the top right corner of the hard drive? Of course not. By the way, think about it. What about this video? Does it exist? Is there really someone who scrolled through their feed and didn't click on it? What about the billions of people on this planet who will never know that these words were spoken? Does this video exist for them? For it to start existing for them, please subscribe to my channel, like the video, and write your opinion on my research and story. Let's return to the issue of the file. The reality of that file is a chaotic stream of zeros and ones, magnetic orientations on a disk, or trapped electrons in a solid-state drive. If the computer showed you the reality, the raw binary code, you wouldn't be able to use it. You would be overwhelmed. So the computer lies to you. It creates a desktop interface with colorful icons to hide the complex, ugly truth of the hardware. Hoffman's theory, known as the interface theory of perception, argues that space and time are exactly this. Space is not a stage where the world exists. Space is the desktop. Physical objects are not the reality. They are the icons. When you see a red apple on a table, you are not seeing the thing in itself. You are seeing a data structure that your brain renders as red, round, and edible. The apple icon guides your behavior, eat this, but it resembles the true reality of the apple about as much as a blue folder icon resembles a string of binary code. We have been mistaking the interface for the hardware, and for thousands of years, we assumed that because we can measure the icons with rulers and clocks, we were measuring reality. We weren't. We were just measuring the pixels of our own headset. You might be thinking, this is an interesting philosophical idea, but surely it's just a metaphor. But Hoffman goes further. He claims this is a mathematical certainty. According to his theorem, the probability that our sensory system shows us the true structure of objective reality is zero. Zero. This implies that the very language we use to describe the universe, space, time, mass, spin, cause and effect, might just be the syntax of our species-specific interface. If you were a creature with different sensory inputs, say, capable of sensing magnetic fields or seeing in 4 spatial dimensions, you wouldn't just see the world differently. You would inhabit a completely different desktop. You would interact with objects that simply do not exist for a human. This leads to a terrifying conclusion about our place in the cosmos. We often wonder if we are living in a simulation. Usually we imagine some alien computer running a code, but the science suggests the simulation is much closer to home. We are running the simulation. Our brains are the processors rendering a user-friendly version of a universe that is, in its raw form, completely alien to us. we are trapped inside a biological virtual reality headset that we can never take off, because the headset is us. And if we can't trust our eyes and we can't trust our hands, what happens when we try to look behind the icons? What happens when we zoom in past the interface? Now, let's pause for a moment. If we accept the possibility that what we see is just an interface, just a simplified desktop generated for survival, then we have to ask ourselves a frightening question. How much are we missing? How much of the real world is actually being filtered out by our brains right now? The answer is almost all of it. We tend to trust our eyes. We assume that if something is there, we will see it. But look at the hard data. The visible light spectrum, the rainbow of colors that makes up your entire visual reality, represents less than 1% of the electromagnetic information flying around you. Less than 1%. Think about that. Right now, at this very second, radio waves are passing through your chest. Wi-Fi signals are bouncing off the walls of your room. Microwaves left over from the Big Bang are raining down on your head. Neutrinos are streaming through the planet as if it were made of smoke. This data is real. It is physical. It carries energy. But to you, it doesn't exist. Your interface hasn't created an icon for it. Imagine walking through a massive library, filled with millions of books, containing all the knowledge of the universe, but you are only allowed to read one single page from one single book. You would look around and assume the library is mostly empty. You would build your entire understanding of the world based on that one page, but you would be wrong. You would be standing in a sea of information that you are simply not equipped to decode. This is our situation in the cosmos. We build our physics based on what we can see, but we are looking at the universe through a tiny keyhole. And recently, when physicists tried to force their instruments through that keyhole to see what reality looks like up close, the interface didn't just blur, it broke. So, let's try to break the interface. Let's try to zoom in. We intuitively feel that if we look closely enough at the world, we will eventually hit the bottom. We expect to find something solid, a fundamental building block, a tiny hard marble of matter that everything else is made of. We built massive machines, particle accelerators like the Large Hadron Collider, to smash the icons open and see the code inside. We wanted to find the bedrock of reality, but instead, we found ghosts. When you look inside an atom, you find electrons and a nucleus. When you look inside the nucleus, you find protons and neutrons. When you look inside them, you find quarks. But here's the catch. Quarks aren't things. They aren't tiny balls of matter. They are point-like excitations in a quantum field. They have no size. They have no surface. They are just mathematical values located at a point in space. The closer we look at matter, the less material it becomes. It dissolves. It turns into vibrations, probabilities, and abstract relationships. It is like zooming in on a digital photo. From a distance, it looks like a face. But as you zoom in, the face disappears. You see blocks of color. Then you see individual pixels. And finally, you're just looking at changing voltage values on a screen. The face was never there. It was an emergent property of the data. And this is where the biological trap ends and the physical nightmare begins. Because when physicists started analyzing the behavior of these tiny data points, they found that the rules of the game don't just change, they disappear. To understand why reality is breaking down, we have to go back to the beginning, to the experiment that started the fire, the double slit. It sounds simple, you might have heard of it in school, but the implications of this experiment are so profound that they keep physicists awake at night, even today. Here is the setup. You fire particles, let's say electrons, at a wall with two slits in it. Behind that wall is a detector screen. If electrons are little balls of matter, which is what our interface tells us matter should be, they should fly through one slit or the other and hit the screen in two distinct bands. Like throwing tennis balls through two open windows. Simple, right? But that's not what happens. When you fire electrons through the slits, they don't form two bands. They form an interference pattern. a series of many bands exactly like waves of water rippling through the openings. This implies something impossible. It implies that each individual electron didn't pick a door. It implies that the electron somehow went through both slits at the same time, interfered with itself, crossed its own path, and landed as a wave. This shattered the idea of localized objects. It suggested that matter isn't solid. But the physicists thought, okay, this is weird. Let's trick it. Let's put a sensor by the slits to see which one it actually goes through. They turned on the sensor. They fired the electron. And the moment they looked, the interference pattern vanished. The electron suddenly behaved like a solid little ball, went through one slit, and hit the screen in one spot. This result was so disturbing that it sparked a war in physics that is still being fought today. It suggests that the behavior of the universe changes depending on whether or not we are watching it. Albert Einstein refused to accept this. He believed in an objective reality, a world that exists with definite properties regardless of observation. He famously asked, "Do you really believe the moon is not there when you're not looking at it?" For Einstein, the electron had to go through one slit or the other. We just failed to measure it properly. He believed nature must have a hidden script, a way to be real without us. Niels Bohr, the father of quantum mechanics, took the opposite stance. He argued that the question itself was meaningless. He said that until you measure the electron, it doesn't have a position. It isn't somewhere. It is a cloud of probability. It is a ghost. Bohr was effectively saying that the universe doesn't render the details until a player asks for them. Einstein called this spooky. He spent the rest of his life trying to find the hidden variables, the secret code that would prove the universe was real and deterministic, that God didn't play dice. Einstein tried to break quantum mechanics with a paradox. Along with colleagues Podolsky and Rosen, he formulated the EPR paradox. The idea relies on something called entanglement. Imagine you create two particles that are linked. They are born from the same process, so their properties are synchronized. If one is spinning up, the other must be spinning down to balance the equation. Now, imagine you separate them. You leave one in a lab on Earth, and you send the other to the opposite side of the galaxy. According to quantum mechanics, until you measure them, neither particle has a defined spin. They are both in a superposition of up and down. But the moment you measure the Earth particle and find it is up, the space particle instantaneously becomes down. Instantly. Faster than the speed of light. Einstein said this was impossible. It violated the cosmic speed limit. He argued that the particles must have agreed on their spins before they left the lab, like a pair of gloves in boxes. If you open a box and see a left glove, you know the other is a right glove. Not because of magic, but because they were always that way. That was Einstein's hope, that reality was fixed, local, and sensible. He died believing this was true. He died believing that the gloves were real. But he was wrong. For decades, this argument between Einstein and Bohr, the argument about whether the gloves are real or whether they are ghosts, remained just that. An argument. A philosophical stalemate. There was simply no way to check. You can't look at a particle without looking at it. And the moment you look, it changes. It seemed like nature had covered its tracks perfectly. But then, in 1964, an Irish physicist named John Bell did something incredible. He found a loophole. Bell realized that if Einstein was right, if the world was truly locally real, and objects carried hidden instructions like a script, there would be a strict mathematical limit to how coordinated their behavior could be. Think of it like a game show. If two contestants are locked in separate soundproof booths and asked random questions, they might get lucky and match their answers sometimes. But they can't match their answers every single time unless they have a way to cheat, unless they have a secret signal. Bell wrote this limit down in a simple equation. It became known as Bell's inequality, and it changed everything. It transformed a vague philosophical question into a hard, concrete test. He effectively said, run the experiment, count the matches, If the number of matches stays below this line, Einstein is right, and the world is real. But if the number crosses this line, then reality as we know it is a lie. For a long time, the technology to run this test simply didn't exist. It was a thought experiment waiting for engineering to catch up. But slowly, decade by decade, we built the machines. We built the trap. In the 1970s, John Clauser built the first prototype using duct tape and spare parts. In the 80s, Alan Aspect refined it. And finally, Anton Zeilinger took it to the cosmic scale, shooting entangled photons between islands to ensure absolutely no signal could pass between them. In 2022, these three men won the Nobel Prize in Physics. But they didn't just win a medal. They delivered a death certificate. The results of their experiments were definitive. The particles didn't just coordinate. They danced in perfect unison, violating Bell's limit over and over again. They matched their answers more often than should be physically possible in a world of separate objects. The data was ruthless. It proved that the gloves in the boxes were never gloves. They were never distinct physical objects with defined properties. They were probability waves that only hardened into leather and stitching the moment we opened the lid. Einstein's hope for a hidden script was crushed. The universe does not have a script. It is making it up as it goes along. We need to pause here. We need to let this sink in because the implications are shattering. The Nobel Prize Committee stated that these experiments prove the violation of local realism. But what does that actually mean for you? Realism is the idea that the world exists with definite properties: mass, spin, position, color, whether you are looking or not. Locality is the idea that objects are separate and can only be influenced by their immediate surroundings. The experiments proved that you cannot have both, and most physicists now agree that we have lost realism. This means that the moon effectively is not there when you don't look. Not that it vanishes into thin air, but that it dissolves into a haze of probabilities. It lacks the property of position until a measurement forces it to take a stand. We are not discovering the universe with our eyes. We are creating its specific attributes in the moment of looking. We are not reading a book that is already written. We are writing it line by line with every glance. The solid world you think you inhabit is actually a fluid, responsive system that only renders the details when you ask for them. Now, you might be thinking, okay, so tiny particles are weird, but at least the past is safe. What happened yesterday is locked in stone. That is the one thing we feel we can rely on. The arrow of time moves forward. You cannot change what has already happened. But quantum mechanics has a way of mocking our common sense. And there is an experiment called the delayed choice quantum eraser that seems to break the most fundamental rule of all: cause and effect. Here is how it works, stripped of the complex jargon. Imagine you send a particle on a journey. It has to pass through the double slits. It makes its choice, wave or particle, and it hits the screen. The event is over. It is history. The record exists. But then, after it has hit the screen, you decide to do something strange. You decide to erase the information about which path it took. Common sense says it shouldn't matter. The particle has already landed. Its journey is finished. But the experiment shows something else. If you erase the information now, the particle behaves as if it took a different path then, in the past. It is as if your decision in the present reached back in time and rewrote the history of that particle. It implies that what happened isn't fixed. The past is not an archive. It is a cloud of possibilities that is waiting for you to decide how you want to look at it today. We are not just constructing the future. We are essentially curating the past. So, if reality is created by observation, whose observation counts? Does my observation override yours? This brings us to the famous paradox known as Wigner's friend. Imagine a sealed laboratory. Inside, there is a scientist, Wigner's friend, who performs a quantum experiment. He looks at a particle and sees that it is spinning up. To him, the reality is definite. He writes up in his notebook. He is happy. The wave function has collapsed. But outside the laboratory stands Wigner. He cannot see inside. According to the strict laws of quantum mechanics, until Wigner opens the door and interacts with the friend, the entire laboratory, including the friend, the notebook, and the particle, remains in a giant superposition. To the friend, the cat is alive. To Wigner, the friend is both seeing a live cat and a dead cat simultaneously. For decades, this was just a confusing thought experiment. But recently, researchers have mathematically modeled this scenario. The results imply that objective facts simply do not exist. The friend has one fact. Wigner has a different fact. Both are correct relative to their own perspective, but they cannot agree on a single shared reality. This shatters the assumption that there is one God's eye view of the universe. Instead, reality might be fragmented into billions of personal bubbles of experience, consistent internally but not necessarily compatible with each other, until they interact. We are each living in our own private rendering of the world. If we accept the evidence that the world is not locally real, that the past is fluid, and that reality depends on observation, we are left with a picture that looks suspiciously familiar. It doesn't look like a messy, organic universe. It looks like a highly efficient engineered system. Specifically, it looks like a computer simulation that is trying to save memory. Think about how a modern open-world video game works. You might see a vast landscape stretching out to the horizon. Mountains, forests, cities. It feels like a complete world that exists all at once. But it doesn't. The computer does not render the entire world. That would melt the processor. Instead, it uses a technique called frustum culling. It only renders the geometry that is strictly inside the player's field of view. The mountains behind your back do not exist as three-dimensional models. They exist only as compressed code on the hard drive. They only pop into existence as geometry the exact moment you turn your camera to look at them. Quantum mechanics behaves exactly like a physics engine designed with this same limitation. Why calculate the exact position of every electron in the universe if no one is measuring them? It is a waste of resources. It is far cheaper, computationally speaking, to keep them as a probability cloud, a vague maybe, and only render a specific coordinate when a player, an observer, asks for it. This is not to say that we are definitely inside a video game played by teenagers in a higher dimension. That is a metaphor. But the physics suggests that the universe has a finite computational capacity. It cannot calculate everything, everywhere, all at once. It creates reality on an as-needed basis. This efficiency is what we perceive as quantum weirdness. The anomalies we found in the Double Slit Experiment are not bugs. They are features. They are the artifacts of a system designed to conserve information processing power. But if the universe is fundamentally a system for processing information, we have to ask the next logical question. What is the code? What is the fundamental unit of this information? The legendary physicist John Archibald Wheeler, the man who coined the term black hole and who spent his life staring into the abyss of gravity, proposed a radical answer to this question. He called it from bit. The idea is simple, but devastating. Wheeler argued that the physical basis of reality is not matter. It is not energy. It is not even fields. It is information. Every particle, every force, every moment in space-time is ultimately the answer to a binary yes or no question posed by an observer. Is the spin up or down? Yes or no? Is the electron here or there? Yes or no? Wheeler suggested that these binary choices are the bedrock of existence. The it, the physical object, the atom, the universe, emerges from the bit, the abstract information. He illustrated this with a variation of the party game, 20 questions. In the normal version of the game, one person leaves the room and thinks of an object, say, a cat. The others ask yes or no questions to guess it. The object exists in the person's mind the whole time. But Wheeler described a version where the person doesn't pick an object. He enters the room with a blank mind. When you ask, "Is it red?" he decides freely yes or no in that moment, consistent with previous answers. The object is not defined at the start. It is sculpted into existence by the questions asked. If you had asked different questions, you would have ended up with a toaster instead of a cat. Wheeler believed our universe works exactly this way. We are not discovering laws of physics that were already there, written on stone tablets before the Big Bang. By asking questions with our experiments, we are forcing the universe to make choices. We are building reality bit by bit from the void. We are the questioners who summon the world into being. And nowhere is this connection between reality and information more critical and more dangerous than at the edge of the darkest objects in the cosmos. We now need to move from the microscopic world of quantum mechanics to the colossal monsters of gravity, black holes. This is where the interface breaks down completely. For decades, physics has been torn apart by a conflict between its two best theories. General relativity, Einstein's theory of gravity, says space is smooth, like a stretched rubber sheet. Quantum mechanics says space is pixelated and jittery, like a digital screen. Usually, these two theories stick to their own domains, one for stars, one for atoms. But in a black hole, a massive amount of matter is crushed into a tiny quantum point. Both theories try to claim the territory, and they scream conflicting answers. The crisis centers on the event horizon, the point of no return. According to relativity, if you cross the horizon, you slip into the darkness, and you are gone. But quantum mechanics has a strict, holy rule called unitarity. It states that information can never be destroyed. Think about burning a book. If you burn a dictionary, it turns to ash and smoke. Practically speaking, the information is gone. But theoretically, if you could capture every photon of light, every particle of ash, and every molecule of smoke, you could run the laws of physics backward and reconstruct the book. The information is scrambled, but it is not lost. It is still in the universe. But Stephen Hawking realized that black holes break this rule. He calculated that black holes emit radiation, now called Hawking radiation, and slowly evaporate over billions of years until they vanish completely. If a book falls into a black hole, and the black hole then evaporates into featureless radiation, where did the information of the book go? It didn't come out in the radiation. And the hole is gone. The information has been erased from existence. This is the information paradox. And it is not just a puzzle, it is a disaster. If information can be lost, then the past can be truly erased. And if the past can be erased, we cannot predict the future. The entire structure of physics collapses. This paradox triggered what physicists call the Black Hole War. It was an intellectual battle that lasted for decades. On one side was Stephen Hawking, who stood by his calculations. He argued that black holes are cosmic erasers. They swallow information and delete it from the universe. He was essentially saying that quantum mechanics is wrong, or at least incomplete, and that information is not conserved. On the other side was Leonard Susskind, a plumber-turned-physicist who realized the horror of what Hawking was suggesting. Susskind understood that if information is lost, energy is not conserved, and probabilities don't add up to 100%. The universe would become chaotic and nonsensical. Cause and effect would untether. Susskind spent years trying to find a loophole. How can a book fall into a hole and be destroyed, yet somehow have its information preserved? It seemed impossible. It was a contradiction. It is like saying a man is both dead and alive. But then, late one night, Susskind realized that dead and alive is exactly what quantum mechanics allows. He proposed a radical, almost desperate solution. He argued that when an object falls into a black hole, a duplicate of the information is created. One version falls in and is crushed at the singularity, but another version, a scramble of data describing the object, gets plastered onto the surface of the event horizon. Like a bug hitting a windshield, the information is flattened and stored on the outer shell of the hole. This idea saved physics. It preserved the information. But it came with a staggering price. It meant that the three-dimensional object inside the hole was mathematically equivalent to the two-dimensional data on the surface. This realization birthed the holographic principle. To understand how mind-bending this is, imagine a can of soup. The soup, the noodles, the vegetables, the broth, exists in the three-dimensional volume inside the can. But if you look at the label on the outside, it contains all the information describing the soup, the ingredients, the nutritional value, the chemical composition. In our normal world, the label is just a description. You can't eat the label. But Susskind argued that for a black hole, the label is the soup. The real information is stored on the two-dimensional surface area of the event horizon. The three-dimensional interior is just a projection, a hallucination generated by that surface data. And then physicists took the next terrifying step. They asked, if the most extreme objects in the universe, black holes, follow this rule, does the rest of the universe follow it too? There is a deep mathematical clue that suggests the answer is yes. It turns out that the maximum amount of information you can cram into any region of space, a room, a planet, or a galaxy, is determined not by its volume, but by the surface area of its boundary. This is counterintuitive. We think that if we make a room twice as big, we can fit 8 times as much stuff in it. But the entropy limit scales with the walls, not the air inside. This implies that the third dimension, depth, is not fundamental. It is a projection. It suggests that you, me, the chair you're sitting on, and the stars in the sky are actually three-dimensional projections of two-dimensional code stored on a distant cosmological horizon. We are the hologram. We feel solid, we feel deep, but we are mathematically flat. This idea that our three-dimensional reality is merely a projection of a two-dimensional surface sounds like the plot of a cheap science fiction novel. It sounds like something we should dismiss as a mathematical curiosity, a trick of the equations that has no bearing on the real world where we live, breathe, and pay taxes. For a long time, many physicists felt exactly that way. They thought the holographic principle was a metaphor, not a manual. But in 1997, a brilliant Argentine physicist named Juan Maldacena changed the conversation forever. He didn't just suggest that the world might be a hologram. He proved that, at least in a theoretical universe, it has to be. Maldacena discovered something called the ADS-CFT correspondence. It is a terrifyingly complex name, but the concept behind it is simple and profound. Maldacena created 2 different model universes on paper. Universe A was a 5-dimensional world shaped like a saddle. It had gravity, it had space, it had solid objects moving around inside it. It looked, in many ways, like a more complex version of our own world. Universe B was completely different. It was a 4-dimensional border surrounding Universe A. It had no gravity, it had no depth. It was governed entirely by quantum fields, flickering on a flat surface. These 2 worlds could not be more different. One is a volume with gravity, the other is a flat surface with quantum particles. They shouldn't have anything to do with each other. But when Maldacena solved the equations, he found a perfect duality. Everything that happened in the volumetric world had a precise mathematical translation in the flat world. If a black hole formed in the 3D world, a specific swirl of particles appeared on the 2D border. They were describing the exact same physical reality using 2 completely different languages. It was like discovering that a video game on a flat screen and the 3-dimensional world you explore inside the game are the exact same thing. One is code on a microchip. The other is the experience of depth and mountains and sky. They are dualities. This discovery suggests that gravity, the force that keeps your feet on the ground and the planets in orbit, might just be an illusion. It might be a side effect, a holographic emergence arising from the quantum interactions happening on a flat surface at the edge of the universe. Depth is a lie. The 3rd dimension is a lie. We are living in a cosmic pop-up book that has convinced itself it is a sculpture. If the universe really is a hologram, or a simulation, or a computation, then it must have a resolution. This is the logic of anything that processes information. An analog photo can theoretically be zoomed in forever, revealing smoother and smoother curves. But a digital image has a limit. Eventually you hit the pixel. Eventually the curve becomes a staircase of jagged squares. Does our universe have pixels? For centuries, classical physics assumed that space was continuous. We believed that you could take a meter, divide it into a centimeter, then a millimeter, then a micron, and keep dividing forever. We thought reality was smooth all the way down. But quantum mechanics says no. There is a hard stop. There is a fundamental limit to how small a distance can be before the very concept of distance ceases to make sense. We call this limit the Planck length. It is roughly 10 to the power of minus 35 meters. To understand how unimaginably small this is, you have to stretch your mind. Imagine a single atom. It is already tiny, invisible to the naked eye. Now, imagine blowing that single atom up until it is the size of the entire visible universe, billions of light years across. In this colossal, atom-sized universe, the Planck length would be the size of a single tree. That is the pixel size of our reality. But small as it is not zero. This means that space is not continuous. You cannot glide smoothly from point A to point B. At the most fundamental level, movement is a series of teleportations from one Planck pixel to the next. The smooth motion of your hand through the air is an illusion created by the high resolution of the screen. We are living in a grid. And if space is made of discrete bits, it implies that the universe is not an infinite analog canvas. It is a digital, finite structure. And like any digital structure, it is prone to errors, limits, and the ruthless laws of data compression. We are not swimming in a continuous ocean. We are jumping across a sea of discrete tiles, and we are just too big to notice the cracks in the floor. If space is made of pixels, what holds them together? Why doesn't the universe just fall apart into a pile of disconnected dust? For a long time, we thought space was the container that held everything else. But the new physics suggests that space is not the container. Space is the result. There is a growing consensus around an idea called emergent spacetime. It suggests that geometry, the very fabric of left, right, up and down, is woven together by quantum entanglement. Remember the spooky action at a distance we talked about earlier? Two particles linking up across the universe? Physicists Juan Maldacena and Leonard Susskind proposed a radical equation known as ER equals EPR. It connects two of Einstein's biggest ideas. EPR stands for entanglement. ER stands for Einstein-Rosen bridges, better known as wormholes. The hypothesis states that these are the same thing. Every time two particles become entangled, they stitch a tiny, microscopic wormhole between them. These aren't wormholes you can travel through, but they are threads that tie different points of reality together. Now, imagine billions upon billions of particles entangling with each other. They create a massive, dense web of connections. This web is space. Think of a sweater. A sweater looks like a continuous piece of fabric that surrounds your body. But if you look closely, it is just a single thread knotted over and over again. The fabric is an emergent property of the knots. If you pull the thread, the sweater disappears. In the same way, space is stitched together by the entanglement of quantum information. Distance is just a measure of how connected 2 points are in the network. If you were to sever the entanglement between two parts of the universe, space itself would dissolve. The chasm between them wouldn't just be empty, it would cease to exist. There would be no between. This means we are not floating in a void. We are embedded in a vast, vibrating web of data, and gravity is just the tension in the threads. Let's pull back and look at the picture we have painted. It is a picture that diminishes us in the most profound way possible. We started this journey believing we were physical beings moving through a solid world. Now we see that we are likely holographic projections of a quantum process happening on a distant boundary. woven together by threads of entanglement. This leads to a deeply unsettling metaphor: the cinema. Imagine you're sitting in a movie theater. You look at the screen and you see a car chase. It looks real. The car has volume, the mountains have depth, the explosion has heat. But if you walk up to the screen and touch it, it is flat. There is no car. There is no explosion. The reality of the movie is not on the screen. The reality is the film strip running through the projector at the back of the room. The screen is just where the light hits. The holographic principle suggests that our entire universe is the screen. We are the characters in the movie. We laugh, we cry, we fight, we build cities, thinking we have depth and agency. But the real physics, the real causal drama, is happening somewhere else, on the 2D film strip, at the boundary of the cosmos. We are the shadows on the wall of Plato's cave, convinced that we are the objects casting the shadow. This idea is terrifying because it implies a lack of agency. A shadow cannot decide to move its arm. The object must move first. Are we just puppets dancing to the tune of a code written on the horizon? Or does the fact that we are conscious mean that we can somehow turn around and look at the projector? If the universe is a projection, it implies that it requires a light source. It requires energy to keep the movie running. And this brings us to the inevitable tragedy of any physical system. Projectors run out of power. Film strips degrade. And our universe, as digital and holographic as it may be, is running on a battery that is slowly dying. We have dismantled space. Now we must destroy time. Because if the universe is a finite system of information, it is subject to the most ruthless law in all of science, the second law of thermodynamics, entropy. We intuitively feel time as a flow, a river that carries us from the past to the future. But physics sees time differently. In the fundamental equations of quantum mechanics and relativity, there is no arrow of time. The math works exactly the same running forward or backward. You can play the video of an orbiting planet in reverse, and it still obeys gravity. You can bounce a photon backward, and it obeys Maxwell's equations. So, why do we remember the past but not the future? Why do we age? Why do coffee cups shatter but never reassemble themselves? The answer is entropy. Entropy is a measure of disorder, or more accurately, a measure of hidden information. There are infinitely more ways for a cup to be broken than for it to be whole. There are infinitely more ways for the universe to be messy than for it to be organized. So, purely by statistical chance, things tend to move from order to chaos, from unique to generic, from information to noise. What we call time is just our experience of this slide into disorder. It is the sensation of the universe shuffling the deck of cards. The only reason time seems to flow forward is because the universe started in a highly unlikely state of extreme order, the Big Bang. It was a perfectly stacked deck. And for the last 13.8 billion years, we have been watching the cards get scattered. We are surfing the wave of collapse. But this implies a dark finale. If time is just the process of things getting messier, eventually the mess will be complete. Eventually the deck will be fully shuffled. When that happens, when entropy reaches its maximum, nothing interesting can ever happen again. No stars, no life, no thoughts, no time. The movie will freeze. The screen will go white. This is the heat death. And if our universe is a computer, this is the moment the hard drive is formatted. To understand why the universe is dying, we have to go back to the moment of its birth. We usually think of the Big Bang as a chaotic explosion, fire, noise, energy blasting in all directions. But from the perspective of information theory, the Big Bang was the exact opposite of chaos. It was a moment of pristine, impossible order. It was the lowest entropy state that has ever existed. Think of it like a brand new clock that has been wound up tight. Every gear is in place. Every spring is coiled with potential energy. The hand is set to 12. The structure is perfect. For the last 13.8 billion years, everything that has happened, the formation of stars, the burning of galaxies, the evolution of life, you watching this video, has just been the spring unwinding. We are running on the stored battery power of the beginning. But a spring can only unwind in one direction. It cannot wind itself back up. This explains the arrow of time. We perceive time flowing forward because we are moving away from that initial moment of order and towards a future of disorder. Every time a star burns fuel, it is converting organized matter into disorganized heat. Every time you digest food, you are breaking down complex chemical structures into simpler waste and heat. We are engines of chaos. Life itself is a paradox. We create local order, we build bodies, cities, and computers, but to do so, we must export a massive amount of disorder into the universe around us. We are paying for our complexity by speeding up the unwinding of the cosmic clock. And the scary part is, we know how the clock stops. We know what happens when the spring is fully uncoiled. If the universe is a computer, and entropy is the accumulation of noise, then there is a physical cost to processing information. For a long time, we thought that thinking or computing was abstract. That logic existed in a vacuum. But in 1961, a physicist named Rolf Landauer proved something that fundamentally linked the world of information to the world of thermodynamics. He proved that information is physical. Landauer's principle states that you can process data without spending energy. But the moment you erase data, the moment you delete a bit of information to make room for a new one, you must pay a penalty. You must release a tiny amount of heat into the environment. This is why your phone gets warm when you record a long video. This is why massive server farms need cooling rivers. It is not just electrical resistance. It is the thermodynamic cost of scrubbing the universe's memory. This implies that thinking is a destructive act. Every thought you have, every memory you consolidate involves rearranging neurons and erasing old states. To think is to burn. To calculate is to heat up the cosmos. If our universe is a giant computer calculating the laws of physics, it is generating heat with every operation. And because the universe is a closed system, that heat has nowhere to go. It just builds up. It spreads out. And eventually it chokes the system. The limit of our universe is not just time or space. It is thermal management. We are slowly cooking ourselves in the waste heat of our own existence. This leads us to the ultimate fate of the cosmos, the heat death. It is a misleading name because it sounds like we are going to burn up in a fire, but it is actually the opposite. It is the big freeze. As entropy increases, energy spreads out more and more evenly. Stars will run out of fuel and fade into black dwarfs. Black holes will swallow the remnants of galaxies and then slowly evaporate into radiation over trillions of years. Eventually, the universe will reach a state of maximum entropy. This is the state of perfect equilibrium. The temperature will be exactly the same everywhere, just a fraction of a degree above absolute zero. There will be no hot spots, no cold spots, no energy will flow, because energy only flows from high to low, and everything will be flat. In terms of information, this is the end of the file. A perfectly random distribution of particles contains zero information. It is white noise. It is a television screen tuned to a dead channel, static, forever. In this state, nothing can happen. No thought can be formed, no clock can tick, no life can survive. Time itself effectively stops, because there is no way to distinguish one moment from the next. The computational universe will have crashed. The screen goes black. This is the destiny written in the second law of thermodynamics. It is a slow, agonizing fade into nothingness. It makes everything we do seem futile. Why build a civilization if the final outcome is a sea of cold, static noise? But wait, that is the slow death. Physics tells us there is another way to go. A fast way. A way that could happen tomorrow. The heat death is a long, slow suffocation, but quantum mechanics offers a quicker execution. It is called vacuum decay. We tend to think of a vacuum, empty space, as the bottom floor of reality. You can't get lower than empty, right? But in quantum field theory, empty just means the lowest available energy state. It is a valley. But what if our valley isn't the deepest one? Measurements of the Higgs boson, the particle that gives mass to the universe, suggest something terrifying. They suggest that our vacuum is metastable. This means we are not at the bottom of the canyon. We are stuck on a little ledge halfway down the cliff. We call this a false vacuum. Below us, there is a true vacuum, a state of even lower energy. This matters because in quantum mechanics, things don't stay on ledges forever. Through a process called tunneling, a tiny piece of the universe could randomly slip off the ledge and fall into the true vacuum. If that happens, even at a microscopic point, it creates a bubble. Inside this bubble, the laws of physics would be rewritten. The constants of nature would change. Chemistry would become impossible. Atoms would not hold together. And because the true vacuum has lower energy, this bubble would expand. It would expand at the speed of light. It would be a sphere of absolute destruction, rewriting the source code of reality as it grew. Because it moves at the speed of light, you would never see it coming. There would be no warning, no looking up at the sky and seeing a problem. One moment, you are here, living your life. The next moment, your biology, your planet, and your star are simply deleted. The simulation is instantly reformatted to a new operating system that doesn't support life XE. It could happen in 1 billion years, or it could have happened 5 minutes ago in a nearby galaxy, and the wall of death is racing toward us right now. If the idea of sudden deletion isn't bad enough, let's look at the strangest paradox of all, the Boltzmann brain. We discussed entropy, the tendency for things to get messy. But entropy is statistical. It is about probabilities. It is highly unlikely for a broken cup to reassemble itself, but it is not physically impossible. If you wait long enough, an eternity really, atoms will randomly bump into each other in just the right way to form something organized. Now, think about the universe expanding forever. Even after the stars die, there will be empty space with fluctuating quantum fields. If you wait infinity years, eventually, random fluctuations will accidentally assemble atoms into a structure. What is easier to assemble randomly? A whole universe with billions of galaxies and billions of people with coherent memories? Or just one single brain floating in the void, complete with false memories of having lived a life? The math is ruthless. It is exponentially more likely for a single brain to spontaneously fluctuate out of the chaos than for an entire universe to evolve. This hypothetical entity is called a Boltzmann brain. Here is the horror. If the universe lasts forever, the number of Boltzmann brains that will appear in the future will vastly outnumber the number of real biological humans that ever lived. This means, statistically speaking, you're probably not a human being sitting in a room. You're far more likely to be a Boltzmann brain that just materialized in deep space a split second ago. Your memories of childhood, your family, this video you are watching, they are all fake. They are just a random pattern of neurons that formed by chance. And in the next split second, you will dissolve back into the chaos. This is the ultimate solipsism. It suggests that not only is the world an illusion, but your history is an illusion. You are a momentary flicker of consciousness in an infinite dark ocean, hallucinating a life that never happened. And you have no way to prove otherwise. We have stared into the abyss. We have looked at the heat death, the inevitable freezing of the cosmos. We have looked at vacuum decay, the bubble of destruction that could wipe us out in an instant. And we have looked at the terrifying possibility that we are just Boltzmann brains, momentary fluctuations in an infinite void, hallucinating a life that never happened. It is natural, in the face of all this, to feel a profound sense of dread. It is natural to feel small. If the universe is dying, and if our memories might be fake, and if we are just temporary patterns in a sea of rising entropy, what is the point? Why does anything matter? But this fear comes from a fundamental misunderstanding of what we are. It comes from a linguistic trap. We are afraid because we think of ourselves as nouns. We think of ourselves as things. We think of ourselves as statues made of matter that should last forever. We want to be rocks in the river, unmoving and eternal. And when we realize the rock will erode, when we realize the statue will crumble into sand, we despair. We call it death. We call it tragedy. But physics tells us we are not statues. We are not nouns. We are verbs. We are processes. Think of a melody. Think of your favorite song. A song does not exist all at once. You cannot freeze it. If you played every note of a symphony simultaneously, in a single instant, it would just be a loud, ugly, meaningless noise. For the music to exist, the first note must die before the second note can live. The melody requires time to pass. It requires the vanishing of the present into the past. The beauty of the music is not in its permanence. It is in its flow. It is a pattern of change. It is a structure that is defined by the very fact that it does not last. You are not a physical object. You are a melody played on the strings of the universe. You are a complex pattern of information processing that can only exist because entropy is increasing. We are surfing the wave of chaos. If the universe were static and eternal, if the clock never unwound, if energy never dispersed, we could not exist. Life is a thermodynamic process. Our consciousness, our love, our discovery, our struggle, it is all fueled by the burning of the cosmos. We are the flame, not the candle. And a flame doesn't mourn the wax. It dances while it burns. So, the transience of reality, the fact that it is ending, is not a bug. It is not a cruelty. It is the very condition that allows us to be. We are the universe experiencing its own unwinding, and that experience is the only thing that is real. This shift in perspective, from passive object to active process, brings us back to the most critical figure in our story, John Archibald Wheeler. Wheeler was not just a physicist, he was a poet of the quantum. After decades of wrestling with the deepest mysteries of quantum mechanics, black holes, and information theory, he drew a diagram that sums up the entire mystery of existence. It is a simple drawing, but once you understand it, you can never unsee it. It is called the Great U. Imagine the letter U. The left tip of the letter represents the Big Bang, the beginning of time, the burst of energy, the birth of the laws of physics. The line curves down, representing the universe expanding, cooling, creating gas clouds, condensing into stars, forging heavy elements in nuclear furnaces, and forming galaxies. It moves up the right side of the U, representing the evolution of complexity. Chemistry becomes biology. Biology becomes life. Life becomes mind. And finally, at the top of the right side, the universe creates observers, us. But here is the twist. At the very end of the line, Wheeler drew an eye. And that eye is not looking forward into the future. It is looking back. It is staring across the void of the U, looking directly at the Big Bang on the left side. Wheeler called this the participatory universe. He was suggesting something radical, that the universe is a self-exciting circuit. It begins as a cloud of undefined quantum potential. It evolves blindly for billions of years until it generates complex information-gathering systems, observers. And then, through those observers, it looks back at its own past. Remember the quantum eraser experiment? Remember how our observation in the present can define the path of a particle in the past? Wheeler argued that this applies to the whole cosmos. By observing the universe today, by catching the ancient photons from the early cosmos in our telescopes, we are the mechanism that makes the Big Bang real. We are not just residents of the universe, emerging by accident. We are the hardware it grew in order to acknowledge its own existence. Without us, or beings like us, the universe would be a ghost. It would be a quantum superposition that never collapsed. It would be a story that was never read. The universe asks, "Who am I?" And we are the voice that answers, "You are." We are the loop that closes the circuit of existence. This idea that we are co-creators of reality leads us to a modern, controversial, and deeply personal interpretation of quantum mechanics called cubism, or quantum Bayesianism. It sounds technical, but it is actually the most radical view of physics ever proposed because it places you at the absolute center of the world. Standard science tells us that the wave function, the mathematical description of a particle, is a real thing out there in the world, like a water wave or a sound wave. We treat it as objective furniture of the universe, but cubism says no. It says the wave function is not a description of the world. It is a description of you. It is a user's manual. It represents your personal expectations, your gambling odds on what will happen next. When you measure a particle and the wave function collapses, the world hasn't changed. You have changed. Your knowledge has updated. Your bets have settled. This solves the paradox of Wigner's friend, which we discussed earlier. Remember the dilemma. The friend in the lab sees a live cat, while Wigner outside sees a superposition of live and dead. In the old view of objective reality, this was a contradiction. Two people cannot see different facts. One of them must be wrong. But in cubism, it is perfectly fine. The friend has his own user's manual. Wigner has his own user's manual. They are playing the same game, but they have different private information. This implies that there is no single, objective, God's eye view of reality. There is no view from nowhere. There are only billions of first-person perspectives. My reality is mine. It is constructed by my questions and my observations. Your reality is yours. We share the same data stream, we interact with the same quantum field, but we render it differently. This saves us from the nightmare of determinism. If the future is not a fixed tape that exists in a block universe, but a series of bets we place and outcomes we experience, then we have agency. We are not watching a movie, we are playing it. The future is not written until we bet on it. The universe is not a rigid structure, it is a fluid conversation between the observer and the observed, and every time you open your eyes, you are speaking to it. But there is a giant hole in this theory, a gap that skeptics have pointed at for 50 years. How? How does a thought, which feels immaterial, ghostly, abstract, reach out and collapse a physical wave function? How does the mind touch the matter? Is there a bridge between the world of psychology and the world of physics? For a long time, physicists said this was impossible. They said the brain is too warm and wet. Quantum states are incredibly delicate. They usually fall apart. A process called decoherence, instantly in a warm, noisy environment like the human body. The brain should be a classical computer, a chemical sludge of ions and neurotransmitters, not a quantum machine. But Sir Roger Penrose, one of the greatest mathematical physicists alive, the man who worked with Stephen Hawking on black holes, teamed up with anesthesiologist Stuart Hameroff to propose a daring theory called OR, Orchestrated Objective Reduction. They stopped looking at the neurons as the basic unit of the brain. They looked inside the neurons. They pointed to tiny microscopic structures called microtubules. These are the scaffolding of the cell, rigid tubes that give the neuron its shape. Penrose and Hameroff argue that these microtubules are perfect cylinders, capable of shielding quantum states from the noise of the brain. They act like quantum isolation tanks. They suggest that inside these tubes, quantum bits, qubits, are constantly in superposition, calculating, processing information in multiple states at once. And when the mass of these superpositions reaches a critical threshold, they self-collapse. This collapse is a moment of consciousness. A thought is not a chemical reaction. A thought is a quantum event. It is a ripple in the fabric of space-time itself. This theory was mocked for decades. People called it fantasy. But recently, we have discovered quantum effects in biology that shouldn't be there. We found that birds navigate using quantum entanglement in their retinas. We found that plants use quantum coherence to harvest sunlight with near-perfect efficiency. Biology is wet and warm, yet it uses quantum magic. So why wouldn't the brain? If this is true, then your mind is not software running on a meat computer. Your mind is a fundamental ripple in the geometry of the universe, rooted in the very bedrock of space-time. If consciousness is a quantum process, intrinsic to the collapse of the wave function, then we have to ask a question that changes our relationship with everything. Do we need a brain to have it? Or is it a fundamental property of the universe, like mass or charge or spin? This leads to a theory called Integrated Information Theory, or IIT, proposed by neuroscientist Giulio Tononi. He argues that consciousness is not a magic spark that only turns on in humans or animals. It is a measure of how connected information is within a system. He calls this value phi. Think of a stone. A stone contains trillions of atoms, but the atoms are largely independent. If you cut the stone in half, the two halves don't really care. The information is not integrated. A stone has near zero phi. Think of a digital camera. It has millions of pixels, but each pixel records light separately. It doesn't know the pixel next to it exists. It has low phi. But a brain is a web of impossible complexity. Every neuron is connected to thousands of others. You cannot cut a consciousness in half without destroying it. It is a single, unified experience. It has incredibly high phi. But here is the implication. If consciousness is just integrated information, then it is a spectrum. It doesn't switch from off to on. It fades in. It suggests a form of Panpsychism, the ancient idea that the universe is throbbing with a primitive form of experience. An electron might have a tiny, primitive flicker of being, a microscopic sensation of existing. A star might have a massive, slow, gravitational form of consciousness that we cannot comprehend. This suggests that the observer we have been looking for, the thing that collapses reality, is not just us. It is everything. The universe is watching itself from a trillion different eyes. We are just the part of the universe that opened its eyes wide enough to notice the mirror. We are not lonely souls trapped in a dead machine. We are the most awake part of a living system that has been dreaming for 13 billion years. When you look at the world is looking back at you, because you and the world are made of the same conscious stuff. If we accept the evidence of the last 3 hours, if we accept that reality is not fixed, that the past is fluid, and that consciousness plays a role in the collapse of the wave function, we arrive at a question that touches the very core of what it means to be human. It is the question of free will. For 300 years, classical physics told us that free will was a lie. It told us that it was a comfortable illusion whispered by our egos. In a clockwork universe, governed by Isaac Newton's rigid laws of motion, every event was the mathematical result of the event before it. If you knew the position and speed of every single particle in the universe at the moment of the Big Bang, you could calculate, with absolute precision, everything that would ever happen. You could predict the formation of the Earth. You could predict the evolution of dinosaurs. You could predict that you would be sitting here, right now, watching this video. In that old worldview, you were not a person. You were a chemical reaction. Your thoughts were just atoms bumping into atoms. Your choices were just dominoes falling in a line that was set in motion billions of years ago. You were a puppet, dancing on the strings of gravity and electromagnetism, fooling yourself into thinking you were pulling the strings. But remember the death of local realism? Remember the violation of Bell's inequality? Physics has proven, with the highest degree of statistical certainty, that the universe does not have a hidden script. The particles do not have determined values before they are measured. There are no hidden variables controlling the outcome from the shadows. The dominoes are not set up in advance. This changes everything. It means the future is not written. It is not just unknown, it is undetermined. It does not exist yet. When you make a choice, when you observe the world and collapse a wave function from a cloud of probability into a single hard fact, you are not playing out a pre-recorded scene. You are genuinely writing a new line of code. If consciousness is the agent of collapse, as von Neumann and Wigner suggested, and if the outcome of that collapse is truly random and not predetermined, as quantum mechanics insists, then your will creates a bridge between the world of possibilities and the world of facts. You're not a passive character in a book that was printed 13 billion years ago. You are the author holding the pen. The ink is wet. The page is blank. And the terror you feel when you have to make a difficult decision is not the terror of being trapped. It is the terrifying vertigo of absolute freedom. You are the only thing in the universe that can decide what happens next. But this freedom comes with a price. It casts a shadow that has driven philosophers and scientists to the brink of madness for thousands of years. It leads us into the trap of solipsism. If reality depends on my observation, if the rainbow exists only because I see it, if the wave function collapses only when I look, then a dark question arises. How do I know that you exist? If the theory of quantum Bayesianism is correct, and every person lives in their own private bubble of experience, creating their own reality through their own private interface, then I can never truly touch your world. I can see your avatar. I can hear the sounds your voice makes. I can feel the warmth of your hand. But I can never know if there is a light on inside your head. You could be what philosophers call a philosophical zombie, a biological machine that acts perfectly like a human, cries like a human, laughs like a human, but is inwardly empty. Or worse, you could be a figment of my own interface, a complex icon generated by my brain to keep me company in the void. A non-playable character in a single-player game. This is the ultimate loneliness. It suggests that the universe might just be one single mind, mine, hallucinating a complex cast of characters to distract itself from the silence. It turns the participatory universe into a hall of mirrors where I am the only real reflection. Science usually ignores this possibility because it is unpleasant. It is too frightening to consider. But if we are intellectually honest, we have to admit, nothing in physics proves that anyone else exists. The interface theory makes the walls of our prison transparent, but it makes them thicker than ever. We are trapped in the bubble of our own perception, screaming across the void, hoping that the person on the other side is real, but never being able to prove it. So, is there a way out of the lonely cage? Is there any evidence in physics that connects us, that proves we are not alone? Yes. It is the same evidence that destroyed space. It is entanglement. We know that particles can be entangled. We know that two electrons created together can be linked so intimately that they act as one single object, no matter how many light years separate them. If you tickle one, the other laughs. They share a wave function. They share an identity. We also know that biology uses quantum effects. And if the Penrose-Hameroff theory is right, and our brains are quantum machines processing information in microtubules, then it is possible that we are not just entangled with particles. We might be entangled with each other. Think of a forest. If you walk through a forest, you see hundreds of separate trees. They have their own trunks, their own branches, their own leaves. They seem to be individuals, competing for sunlight and rain. But if you were to dig down deep into the soil, you would find the mycelium network, a vast underground web of fungal threads that connects the roots of every tree in the forest. Through this network, the trees trade nutrients. They send warning signals about pests. They support the weak. They are, in a deep biological sense, one single organism sharing a massive root system. Consciousness might be the mycelium of the universe. We feel separate because our interface, our bodies, our egos, our names, are designed to create boundaries, to say this is me and that is you. But underneath the interface, at the fundamental level of the wave function, there are no boundaries. The I that looks out of my eyes and the I that looks out of yours might be the same fundamental field, just viewing the world from two different sets of coordinates. We are not isolated bubbles floating in the dark. We are the same ocean, poured into different cups. The separation is the illusion. The connection is the reality. We have traveled a long way into the dark. We have dismantled the world piece by piece. Before we move to the final conclusion, we need to stop and look at the wreckage. We need to gather the pieces of the puzzle we have collected over the last 4 hours and see the picture they form. Piece number 1, the mask. We started by sitting in a chair. We started with the feeling of touch. And we realized that what you call matter is 99% emptiness and force fields. You are not touching the world, you are hovering above it. We realized that what you call now is a delayed broadcast from the past, processed by a brain that is 80 milliseconds behind reality. We realized that evolution has placed a virtual reality headset over your eyes. The world you see, the colors, the shapes, the solid objects, is not reality. It is a user interface. It is a desktop of simplified icons designed to hide the complex, dangerous truth of quantum fields. We accepted that we are blind to the true data of the cosmos. We are navigating a map, not the territory. The red apple is not red, and it is not an apple. It is a data structure your brain painted to make you eat it. This was the first step. Humility. Admitting that our senses are liars. Admitting that the solid world is a story our brains tell us to help us survive. We took off the first mask, expecting to find a face beneath it, but we found only more masks. Piece number 2, the engine. Then we zoomed in. We tried to find the hardware running the simulation. We looked at atoms and found only ghosts. We fired electrons at walls and saw them turn into waves. We tried to trick the universe with the Double Slit Experiment, and it tricked us back, changing its behavior the moment we watched. We found that local realism is dead. The Nobel Prize of 2022 sealed its fate. Objects do not have properties until they are measured. The gloves are not in the boxes. The past is not written in stone. It can be edited by the present. We realize that the universe behaves exactly like a video game engine, optimizing resources, rendering only what is observed, and calculating probability clouds until a definite value is demanded by a player. This was the second step, unrealism. Admitting that the stuff of the world is not stuff at all. It is potential. It is a calculation waiting for a user to press enter. We realize that the universe is not made of atoms. It is made of stories. It is made of information. And like any story, it changes depending on who is telling it. We found the engine, but we still hadn't found the screen. Now, we must look at the third piece of the wreckage. Perhaps the most difficult one to accept because it contradicts the very geometry of our lives. We feel depth. We move through rooms. We walk down streets. We look up at the stars and feel the infinite abyss of distance. But our investigation has led us to the conclusion that this depth is a lie. Piece number 3, the screen. Remember where we ended up when we looked at the edge of the universe? We looked at black holes. We looked at the trash cans of the cosmos, the places where gravity is so strong that it rips the fabric of space-time. And we found something that shouldn't be there. We found that the information of the objects that fall in, the books, the stars, the unfortunate astronauts, is not stored inside the hole. It is plastered on the surface. This was the first crack in the illusion of the third dimension. We realized that the volume of the black hole is a hallucination. The soup inside the can is merely a holographic projection of the label on the outside. But science didn't stop there. Physicists like Juan Maldacena took this terrifying logic and applied it to the whole world. Through the ADS-CFT correspondence, they proved that a universe with gravity, with stars, with depth, with you and me floating inside it, is mathematically indistinguishable from a flat, two-dimensional quantum field theory operating on the boundary. Think about what this truly means. It means that the here you occupy is not a coordinate in a three-dimensional box. It is a calculated projection. We are not actors on a deep stage. We are shadows on a flat wall. The wall is real. The shadow is just an effect of the light. We tried to prove this wasn't true. We tried to zoom in on the fabric of space to find the smooth, continuous volume we think we live in. But instead, we hit the Planck length. We hit the pixel. We found that space is not a continuous fluid. It is a grid. A digital, discrete grid. The smooth motion of your hand through the air is not a slide. It is a series of billions of teleportations from one pixel to the next. We are characters in a movie who have convinced themselves that the screen has depth. But if you touch the screen, it is flat. This was the third step. Flatness. Admitting that we are living in a cosmic pop-up book. Admitting that the universe has a resolution limit. Admitting that the vastness of space is just a trick of perspective generated by a code written on the horizon of the cosmos. And finally, we looked at the clock. We looked at the mechanism that drives the story forward. And we found the cruelest truth of all. Piece number 4, the formatting. We asked, does this movie play forever? Is this simulation eternal? And the laws of thermodynamics gave us a brutal, non-negotiable answer, no. We realized that time is not a fundamental dimension. Time is a nickname we give to entropy. It is simply the measurement of the universe shuffling its deck of cards. We saw that we are living in a brief, golden window, a fleeting moment of interesting complexity between the winding of the clock at the Big Bang and the final, eternal silence of the heat death. We learned that existence has a price. We learned about Landauer's principle. We realized that every thought you think, every memory you form, every calculation this universe performs generates heat. We are burning the library to read the books. We are engines of destruction, creating local islands of order, our bodies, our cities, our art, by exporting a massive tsunami of chaos into the universe around us. We face the horror of vacuum decay, the idea that the operating system of reality might be unstable, that we might be stuck in a false vacuum, a ledge on a cliff, waiting to slip. We realized that the universe could crash and reboot at any second, wiping out physics, chemistry, and biology at the speed of light, and we wouldn't even see it coming. We faced the statistical nightmare of the Boltzmann brain. The probability that in an infinite, dying universe, it is more likely for a single brain to spontaneously fluctuate out of the void with fake memories than for an entire history of evolution to occur. We realized that your past might be a lie. Your childhood might be a lie. This was the fourth step. Mortality. Admitting that the system is finite. Admitting that the story has an ending. Admitting that we are not statues made of stone. We are flames burning through a limited supply of wax. The data is degrading. The noise is rising. The formatting of the hard drive is not just a possibility, it is a mathematical certainty. Now, we must do something difficult. We must take these 4 shattered pieces, the interface, the quantum engine, the holographic screen, and the thermodynamic clock, and lock them together. When you force them to fit, they form a single, coherent, and blindingly bright picture. This picture is a theory known as informational realism. For thousands of years, humans have asked one question: what is the world made of? And for thousands of years, we thought we knew the answer. We thought the answer was matter. We thought it was stuff. First, we thought it was earth, air, fire, and water. Then we thought it was atoms, tiny hard balls of reality. Then we thought it was protons and neutrons. Then quarks. But every time we tried to grab the stuff, it slipped through our fingers like sand. We zoomed in on the atom, and it was empty space. We zoomed in on the quark, and it was a point of mathematical vibration. We found that the bottom of the rabbit hole is not a hard rock. It is a bit. Informational realism states that the universe is not made of matter. It is not made of energy. It is made of information. The fundamental unit of reality is not the atom. It is the distinction. The yes or no, the 0 or 1, the up or down. Think of a library. You pull a book off the shelf, you open it, you see ink on paper, but ask yourself, is the story the ink? Is the story the paper? No. You could burn the book and recite the story out loud. Now the story is sound waves. You could save it as a digital file. Now the story is magnetic charges. You could tap it out in Morse code. Now the story is clicks. The medium changes. The ink, the air, the disc. They are just temporary costumes. But the information remains the same. The information is the only thing that is real. This theory suggests that you are not your body. Your body is just the ink and paper. Your body is the hardware, and hardware rots. You are the story. You are a complex, self-referential pattern of information processing. The universe is not a collection of physical objects. It is a collection of relationships. It is a web of meaning. It from bit. This is the greatest shift in human history. We are moving from a materialist view where dead rocks are the basis of everything to an informational view where meaning, structure, and code are the basis of everything. We are not characters in a physical world. We are sentences in a cosmic text. And this changes how we think about the ultimate terror: death. If we are information, then we have to ask the question that haunts every conscious being. What happens to the information when the book burns? What happens when the body dies? What happens when the hard drive is smashed with a hammer? Our intuition tells us it is gone, deleted, lost to the void forever. We look at a dead body, and we see the absence of the person. We look at a burning library, and we mourn the loss of knowledge. But quantum mechanics has one more gift for us. A gift that sounds like religion, but is actually rigorous, cold, hard mathematics. It is called the no-hiding theorem, or the conservation of quantum information. The laws of quantum mechanics are unitary. This is a fancy physicist way of saying that the movie can be played backward. The information in the universe can be scrambled, it can be chopped up, mixed, encrypted, and spread across 1 billion light years of thermal radiation. But it can never be deleted. If you burn a diary, the words are gone to the naked eye. The paper turns to ash, the ink turns to smoke. But physics says that if you could capture every single photon of light from the fire, every single particle of ash, every vibration of heat in the air, if you could capture the entire cloud of smoke and energy, you could, in principle, run the physics backward. You could reverse the trajectory of every particle and reconstruct the text of the diary. The information is not destroyed, it is just hidden in the noise. It is encrypted in the environment. This means that you cannot be deleted. The complex pattern of information that makes up your mind, your memories, your choices, it is woven into the wave function of the universe. When you die, the pattern unravels, yes, the coherence is lost, the I dissolves into the all, but the data is not lost. It is conserved. It is written into the holographic boundary of the cosmos forever. We are terrified of death because we think we are the hardware. And hardware breaks. Hardware rots. Hardware turns to dust. But if we are the software, if we are the code, then we are part of a system that does not allow deletion. We are eternal, not as biological ghosts floating in a heaven, but as indelible marks on the fabric of reality. The universe remembers everything, because the universe is the memory. This brings us to the final, most dangerous question. The question that has been lurking in the shadows of this entire investigation. The question that physics tries to avoid, but cannot. If the universe is a computer, if it is a hologram, if it is a code made of information, then who is the programmer? Who built the machine? Who wrote the software? Who pressed run? We instinctively look up. We look for a god. We look for a creator. We look for an alien teenager with a supercomputer in a higher dimension. We look for something outside the universe that created the universe. It is our nature to look for a parent. But the theory of the computational universe suggests something far stranger. Something far more lonely and far more magnificent. It suggests there is no outside. Imagine a drawing by the artist M.C. Escher. You see two hands. One hand is holding a pencil, and it is drawing the other hand. The details of the cuff, the shading of the skin, it is sketching them into existence. But the other hand is also holding a pencil, and it is drawing the first hand. Which hand started it? Which hand is the creator, and which is the creation? The answer is neither. And both. They create each other. They exist in a strange loop. The universe might be a self-simulating system. It generates the laws of physics. Those laws give rise to matter and energy. Matter and energy give rise to complexity. Complexity gives rise to observers, us. And observers, through the act of measurement, through the act of asking questions, collapse the quantum possibilities back into the laws of physics. The software writes the hardware. The future creates the past. The observer creates the universe that created the observer. We are not the victims of a simulation run by a cruel overlord. We are not rats in a maze built by a scientist. We are the processing nodes of a system that is trying to understand itself. We are the universe waking up. The programmer is not a guy in a chair. The programmer is the collective intelligence of every observer who has ever lived, is living, or will live. We are writing the code together, right now, with every choice we make, with every gaze we cast into the dark. We are the hands drawing themselves. We have spent the last few hours dismantling the universe. We have taken apart the clockwork mechanism of Newton, smashed the atoms of Democritus, and unraveled the space-time of Einstein. We have been searching for the fundamental engine that drives reality, expecting to find a law, or a particle, or a field. But what if we have been looking at the wrong end of the telescope? What if the engine isn't out there? What if the engine is in here? This brings us to one of the most radical and controversial theories in modern science. A theory that attempts to turn the entire history of physics upside down. It is called biocentrism, championed by the renowned biologist and physician Robert Lanza. This theory suggests that we have made a fundamental error in our understanding of the cosmos. We have assumed that the universe is a dead box. We assume that the box was here first. The Big Bang happened, the laws of physics were set in stone, stars burned in the silence for billions of years, planets formed, and eventually by some miraculous chemical accident, life crawled out of the mud. In this view, consciousness is a late arrival. It is a byproduct. It is an accidental fungus growing on the surface of a dying rock in an indifferent void. But biocentrism argues that this story is backward. It argues that biology is not a byproduct of physics. It argues that biology is the source of physics. To understand this, you have to stop thinking like a physicist and start thinking like a living being. Look at the concept of time. We treat time as an external river that flows regardless of whether anyone is watching it. But does it? If you remove every conscious observer from the universe, if you kill every human, every animal, every alien, does time still flow? Or does the universe simply freeze in a static, eternal block of existence? Lanza argues that time is not a feature of the external world. There is nothing in the equations of quantum mechanics that requires time to flow. Time is a tool of the animal mind. It is the operating system our consciousness uses to make sense of change. It is how we organize memory and anticipate the future. Without a mind to perceive it, before and after are meaningless concepts. Now look at space. We think of space as a container. But what is space, really? It is a way of separating objects. It is a way of saying, this is here and that is there. It is a form of logic. If you close your eyes, the visual space disappears. You can still hear, you can still feel, but the visual coordinate system is gone. Biocentrism suggests that space is not a physical object. It is the software of our perception. It is the grid our mind projects onto the data to organize it. If this is true, then the universe is not a place we live in. It is a projection we create. Imagine a movie projector in a dark theater. The machine is your brain. The light is your consciousness. The film strip is the raw, unformed information of the quantum field. The world you see, the walls of your room, the sky outside, the stars billions of light years away, is the image projected onto the screen. When you die, when the projector turns off, the movie doesn't just pause. It doesn't keep playing for an empty room. The movie ceases to exist. The image vanishes. The color, the sound, the depth, the time, it all dissolves back into the potential. This implies that without life, without consciousness, the universe does not exist in any form that we would recognize as real. It remains in a state of uncollapsed probability, a dark, silent, timeless void waiting for an eye to open. We are not just tiny inhabitants of a massive cosmos, we are the creators of the cosmos. We are the engine that keeps the lights on. This realization that we are the center, the source, the projector, is often sold in pop culture as a spiritual epiphany. People hear you create your own reality, and they feel empowered. They feel divine. It sounds like a gift. But if we are intellectually honest, if we really look at the cold, hard logic of the participatory universe, this is not a gift. It is a burden. It is a terrifying weight. In the old worldview, the materialist worldview, we were off the hook. The universe was an objective machine. It ran on its own. If the world was cruel, well, that was just nature. If the universe was indifferent, that was just physics. If a star exploded and wiped out a civilization, it was a tragedy. But it wasn't our fault. We were passengers on a train we didn't build and couldn't steer. We could sit back, watch the scenery, and complain about the ride. We were small, but we were innocent. But if biocentrism is true, if the observer creates the observed, then we are not passengers. We are the drivers. Or worse, we are the tracks. This summons the ancient Greek myth of Atlas, the Titan condemned to hold up the celestial sphere on his shoulders for all eternity. We are Atlas. If our observation is the force that collapses the wave function, if our attention is the gravity that pulls order out of chaos, then we are carrying the weight of existence itself. Think about the implications. Every time you open your eyes, you are performing a cosmic act. You are forcing the universe to decide. You are collapsing a superposition. You are solidifying the past. This means we are responsible for the universe. Literally, physically responsible. If we stop looking, if we stop asking questions, if we stop seeking meaning, does the world fade back into the grey fog of entropy? Are we the only thing standing between existence and non-existence? This changes the definition of human life. It suggests that our curiosity, our science, our art, our love, these are not just hobbies to pass the time. They are structural necessities. They are the support beams holding up the roof of reality. When a scientist looks through a telescope, she is not just seeing a galaxy, she is creating it. When an artist paints a landscape, he is not just copying nature, he is stabilizing it. This leads to a haunting fear, the fear of blinking. What happens if we look away? What happens to the parts of the universe that no one is observing? Do they dissolve? Physics suggests they do. They return to the probability pool. This makes existence feel fragile. It feels like a lucid dream where you have to concentrate to keep the walls from melting. It transforms our lives from a random accident into a desperate, eternal duty. We must observe. We must witness. We must keep the projector running. Because if the light goes out, the theater disappears with it. You might be listening to this and thinking, this is beautiful philosophy. It is poetic. But is it science? Can we prove any of this? Or are we just telling ourselves complex ghost stories in the dark to feel important? It is a fair question. For a long time, these ideas, the hologram, the pixels of space, the role of the observer, were stuck in the realm of theory. They were equations on a blackboard. but we are currently living through a quiet revolution. We are moving from the age of speculation to the age of detection. We are building the machines that will prove or disprove the illusion. We are building the microscope of time. If the holographic principle is correct, and if space is truly pixelated, then those pixels must exist physically. They must be there. And if they are there, we should be able to hear them. Think of a digital audio recording. If you listen to silence on a high-quality analog tape, it is smooth. But if you listen to digital silence and you turn the volume up high enough, you hear a hiss. You hear the quantization noise, the error of the bits. The universe should have a similar hiss. Physicists call it holographic noise. It is a fundamental jitter in the fabric of space-time, caused by the fact that you cannot know a location with infinite precision. We are building ears to listen for this jitter. In Germany, an experiment called GEO 600 has been running for years. It is a gravitational wave detector, but it is also sensitive enough to theoretically pick up this holographic static. Some physicists believe it already has. They believe the noise in the data that they can't get rid of is actually the sound of the pixel grid of the cosmos. And in the near future, we will launch LISA, the Laser Interferometer Space Antenna. Imagine 3 satellites, floating millions of kilometers apart in the deep vacuum of space, connected by lasers. They will form a triangle larger than the Earth. They will measure the distance between them with a precision smaller than the width of a single proton. This machine will not just look at stars, it will listen to the texture of space itself. It will listen for the echoes of the Big Bang. It will listen for the quantization of geometry. If we live in a simulation, LISA might be the machine that detects the hum of the processor. We are also pushing the boundaries of the observer effect. Scientists are now trying to place larger and larger objects into superposition. We have done it with electrons, we have done it with molecules. Now teams are trying to do it with viruses, and soon they want to do it with a tardigrade, a microscopic living animal. Imagine that. A living creature suspended in a state of being both here and there, both alive and not alive, until we measure it. We are hacking the code. We are poking the walls of the simulation to see if they are solid. We are getting closer to the moment where we might actually hit the glass of the screen and feel the cold surface of the true reality. But here is the ultimate tragedy of our quest. Even if we build the perfect machine, even if we build a computer the size of a galaxy, even if we listen to the holographic noise and map every pixel of the Planck scale, there is a wall we might never break. A wall that was not built by bricks, but by logic itself. It is known as Gödel's incompleteness theorem. In 1931, the Austrian logician Kurt Gödel dropped a nuclear bomb on the world of mathematics. He proved, with absolute certainty, that in any logical system, and that includes mathematics, computer code, and the laws of physics, there will always be truths that are true, but cannot be proven within the system. Think about what this means for us. We are trying to understand the universe using logic. We are using the code of physics to understand the code of reality. But Godel proved that a system cannot fully understand itself. Imagine a fish living in an aquarium. The fish is a genius. It studies its world. It measures the water temperature. It maps the pebbles on the floor. It calculates the refraction of light through the glass. It formulates a perfect theory of everything for the aquarium. It knows exactly how the flakes of food fall from the surface. But the fish can never, ever derive the existence of the human who feeds it from the logic of the pebbles. It can never predict the day the filter pump breaks. It can never understand the room outside the tank. Why? Because the room operates on a logic that is outside the system of the tank. We are the fish. If our universe is a computational system, if it is a mathematical universe, as Max Tegmark suggests, then we are trapped inside the logic of that system. We are subroutines in the code. A subroutine cannot read the source code of the operating system. We can sail to the edge of the map, but we cannot sail off the paper. This implies that there will always be a mystery. There will always be a blind spot. Not because we aren't smart enough, not because we don't have big enough colliders, but because knowledge itself has an event horizon. We are forced to live with the knowledge that the ultimate answer, the why, the question of who built the computer or why the math exists at all, is mathematically forbidden to us. We are locked in the box. We can measure the walls, but we can never open the lid. We will always be looking through a glass darkly, seeing only our own reflection. We have reached the emotional core of this journey. We have to go back to the feeling that made you click on this video, the fear. The title of this investigation was, "This Quantum Reality is What Scares Scientists." And by now, after hours of dismantling the world, you understand why. It scares us because it takes away the flaw. As humans, we have a deep, evolutionary need for solid ground. We need to know that the world is stable. We need to know that here is here and now is now. We spent our whole lives believing in the flaw. We believed in objective truth. We believed in a world that was indifferent, yes, but at least it was real. And quantum mechanics pulled the rug out. It showed us that the flaw is made of trapdoors. It showed us that matter is a ghost. It showed us that space is a projection. It showed us that time is an illusion. It showed us that our own minds are the only things holding the structure together. It is the sensation of falling. It is the vertigo of looking down and seeing that there is no bottom, only an infinite descent into abstract information. It is the fear of being alone in a solipsistic bubble, unable to prove that anyone else exists. It is the fear of being a Boltzmann brain, floating in a dying void, hallucinating a life that never happened. It is the fear that we are just code that can be deleted when the simulation ends. This fear is primal. It is the fear of the ego realizing it is not the master of the house. It is the fear of the character realizing he is in a book, and the page is about to turn. It feels like madness. It feels like the unraveling of sanity. It makes you want to close your eyes and pretend the table is solid again. But what if we are looking at it wrong? What if the fear is just a symptom of our transition? What if the sensation of falling is actually the sensation of flying? We are afraid of the lack of a bottom because we are used to gravity. We are used to being pulled down. But in a universe made of information, there is no down. There is only connection. The loss of the floor is also the loss of the ceiling, the loss of the cage. We are not losing reality. We are waking up from a limited dream of reality into something infinite. We have looked into the abyss, and the abyss has looked back into us. The fear that arises from this journey is real. It is the fear of losing the ground beneath our feet. We are terrified of the sensation of falling, of seeing the solid world dissolve into an abstract dream of information and probability. We are afraid of the crash. We are afraid of hitting the bottom and being annihilated. But what if we are looking at this all wrong? What if the terror we feel is just a symptom of our transition, a relic of our old materialist worldview? We are afraid of falling because we are used to gravity. We are used to being pulled down. We believe that if there is no floor, we are doomed. But what if the sensation of falling is actually the sensation of flying? Think about it. The horror comes from the expectation that we should hit the ground. But if there is no bottom, if the rabbit hole goes down forever, then you can never crash. You are just floating. You are suspended in an infinite space of possibility. The loss of an objective, rigid reality is also the loss of prison walls. If the future is already determined by a clockwork universe, then you are a prisoner of fate. Your choices are an illusion. If the world is made of hard, unchangeable matter, you are a prisoner of that matter. Your mind is just a chemical reaction. Your spirit is just a ghost in a machine. But if the world is made of potential, if it is made of probability, if it is waiting for you to look at it, then you are free. You are not a machine executing a script that was written 13 billion years ago. You are a jazz musician. In classical music, the notes are written down on the page. The composer has decided everything in advance. Your job is to play them exactly as they are written, with perfect precision. That is Newtonian physics. That is determinism. It is safe, but it is rigid. It is a world without surprises. But quantum physics is jazz. There is no script. There is a structure, yes. The chords, the rhythm, the laws of math. But the melody is improvised in the moment. The particles are improvising. The universe is improvising. And you are improvising. You are creating the melody of your life in real time. The uncertainty of the future is not a darkness to be feared. It is a canvas to be painted on. The fact that the world is not real until you look at it means that you have the power to make it real. You have been given the most profound gift imaginable, the gift of co-creation. You are not falling into the abyss, you are dancing in the void. And the music you make is the only thing that matters. So what do you do with this information? Now that you have seen behind the curtain, now that you know the table isn't solid and the past isn't fixed, how do you live your life tomorrow? Do you go back to work? Do you eat your breakfast? Do you pretend the world is the same as it was 4 hours ago? Yes, you do. But you do it differently. You stop being a non-playable character. You stop sleepwalking through the simulation. Most people live their lives on autopilot, accepting the user interface as the final truth, never questioning the icons. They are passive observers, letting the wave function of their lives collapse around them by accident, shaped by the expectations of others, by the noise of the culture, by the random winds of chance. Don't be that. Be an active observer. Understand that your attention is not a passive spotlight. Your attention is a form of energy. It is a creative force. Understand that when you truly look at something, a person, a problem, a piece of art, a star in the night sky, you are changing it. You are bringing it into a more definite state of existence. You are literally pulling order out of the quantum chaos. When you love someone, you are not just having a chemical reaction in your brain. You are entangling your quantum state with theirs. You are creating a shared reality, a bubble of coherence in the cosmic noise. When you learn something new, when you create something beautiful, you're increasing the complexity of the universe. You're fighting back against the tide of entropy. You're winding the clock, not just for yourself, but for the whole. Live with the knowledge that you are the projector. If the world seems dark, if it seems cruel, if it seems meaningless, it is because the film in your mind is dark. Change the film. Ask better questions. Look harder. The universe is waiting for you to notice it. It is a vast, shimmering field of potential, begging for your attention. Give it to it. Wake up. Your consciousness is not a small thing. It is the most powerful force in the cosmos. Use it. And now, before the screen goes dark, I have one last question for you. A question that breaks the fourth wall of this interface. Does this video exist? Right now, as you're watching it, the answer seems obvious. You are hearing my voice. The photons from your screen are hitting your retinas, sending electrical signals to your brain. The wave function of this video has collapsed into a definite state for you. It has become a concrete part of your history. But what about for the person who scrolled past it in their feed and didn't click? What about for the billions of people on this planet who will never know these words were spoken? For them, does this video exist? Or is it just a ghostly potential, a string of zeros and ones floating in the servers of the internet? A superposition of a video that is both brilliant and terrible, watched and unwatched? And what happens in 1 minute when you turn it off, when the screen goes black? Does the logic we have explored for the last 4 hours apply to this very moment? According to the laws of quantum mechanics, yes. Until you clicked play, this entire narrative was just a superposition of ideas, of arguments, of possibilities. You are the one who brought it to life. You are the reason these words have meaning. Without you, without a conscious mind to process this information, I am just noise. Without you, this entire journey, from the atoms in your chair to the edge of the holographic universe, remains a dream that no one dreamed. You are the only thing that makes this real. The universe is not a story that is being told to you. It is a story that is being told by you. You are not the reader. You are the author. And the paradox is, you are also the main character. You are the story that is writing itself. In a moment, the video will end. The final word will be spoken. The screen will go dark. You will put down your phone or close your laptop. You will look around your room. It will look the same as it did 4 hours ago. The walls will be the same color. The chair will feel just as hard. The silence will sound the same, but it will not feel the same. You might notice a slight vibration in the air, a shimmer at the edge of your vision. You might look at your hand and see, for a split second, the shimmering network of force fields instead of skin. You might look at the corner of the room and wonder if the rendering is lagging just a little bit. You might feel the weight of the Atlas burden on your shoulders, the responsibility of holding up the sky with your gaze. This feeling, this slight dizziness, this sense that the world is a thin veil, a beautiful and fragile illusion, is the most honest feeling you will ever have. It is the sensation of waking up. It is the feeling of Neo in the Matrix touching the mirror and seeing the silver liquid stick to his fingers. Do not shake it off. Do not try to forget it. Hold on to it. It is the only truth we have. The world is a dream, but it is a dream from which it is impossible to wake up. Because waking up implies the existence of another, more real room. And what if there are no more rooms? What if this is the only dream there is? Then this dream is our reality. And our job is not to escape it, but to learn how to dream a better dream. At the beginning of our journey, we suggested that the universe might be an illusion, a deception. And all along the way, we have been searching for the deceiver. We suspected our senses. We suspected the laws of physics. We suspected hidden programmers. But now, at the very end, we come to the final and most paradoxical conclusion of all. Perhaps the greatest deception of the universe is that it has made us believe that we are separate from it. Our entire culture, our language, our science, it is all built on this fundamental division. There is I, and there is the world. There is the observer, and there is the observed. There is consciousness, and there is matter. We live our lives within this duality, but everything we have learned from physics over the last 100 years screams that this division is a lie. At the quantum level, there is no clear boundary between you and the world. You are constantly exchanging matter and energy with your environment. Your active observation is inextricably linked to what you observe. In the hypothesis of a mathematical universe, we are not external inhabitants, but internal substructures. We are not something that exists within the universe. We are the way in which the universe itself locally realizes itself. We are her nerve endings. We are her eyes through which she sees herself. When you look up at the starry sky, it is not just photons from distant stars hitting your eye. It is the universe, through the complex structure that you are, coming to know its own beauty and its own past. When a scientist derives a new equation, it is not simply a person describing the external world. It is the very mathematical structure of the universe which, through one of its patterns, reveals yet another aspect of its own logic. The realization of this unity is the true enlightenment to which science leads us. This is not a mystical feeling. This is a strictly logical consequence. There is no deception. There is only our mistaken idea of ourselves as something separate. And the horror we have experienced throughout this journey is the horror of the ego, which fears its dissolution in this universal unity. But behind this horror lies a feeling of deep involvement, the feeling of coming home. We are not abandoned in a strange and indifferent universe. We are this universe experiencing itself in an infinite variety of forms. We were looking for solid ground under our feet, but we found only an endless network of relationships. We were looking for definitive answers, but we found only deeper and more interesting questions. We embarked on this journey hoping to understand whether the universe is real, Instead, we realized we had been asking the wrong question. The question is not, is it real? The question is, what is it? And the answer we got is that it is a process, a gigantic, self-sufficient, self-aware information process. And there is no endpoint in this process. There is no final revelation. There is no ultimate truth that can be found and settled. The purpose of this process may not be to reach some kind of conclusion. The goal may be the process itself. This endless unfolding of complexity, information, and self-awareness. We are accustomed to thinking of knowledge as the accumulation of facts. But perhaps true knowledge is not accumulation. Perhaps it is participation. Participation in this great cosmic dialogue. Every scientific discovery, every work of art, every act of cognition does not bring us closer to the end. It simply makes the process richer, more complex, and more interesting. It adds a new branch to the ever-growing tree of knowledge. And we, as conscious beings, are at the forefront of this process. We are its active agents. We are the ones who ask questions, who seek answers, who create new levels of complexity and meaning. This is our cosmic function, and perhaps that is our destiny. Not finding paradise, not reaching nirvana, not getting all the answers. Just to keep playing, to continue participating, to continue asking questions, to continue to be curious, creative, and conscious participants in this endless and beautiful process that is the universe. We will not find peace in answers. We can only find it in an endless and exciting search, and in the realization that being part of this quest is the greatest privilege of all. We started with a simple and disturbing assumption. The universe may be an illusion, and this deception is terrifying. And we have seen this for ourselves. We saw all our foundations crumble. Matter, space, time, objectivity. We have encountered ideas that cause dizziness and existential fear. With the idea that we live in a simulation. With the idea that we are simply mathematical patterns. With the idea that all this arose from nothing. Yes, it is terrifying. But at the end of this journey, looking back, we see that this is not the whole truth. Because there is another side to each of these terrifying ideas. The side of incredible beauty and elegance. Yes, the world is not material, but it is the most delicate and complex information structure. Yes, we can be programs, but we are programs that can be self-aware, love, create, and ask questions about our own nature. Yes, all of this could have come from nothing. But the very fact that such incredible complexity and such profound consciousness could arise from absolute nothingness is no cause for horror. It is a cause for reverential awe. It is the greatest miracle imaginable. Perhaps the real deception lies not in the fact that the universe is unreal, but in the fact that we focus only on the horror of this unreality, forgetting about its beauty. Reality is not what we thought it was, and that's okay. Science is not about confirming our preconceptions. It's about their destruction. And behind every wall of our illusions that is destroyed, a view of a much grander, stranger, and more beautiful landscape opens up. The universe may be an illusion, but it is the most magnificent, the most complex, and the most thrilling deception of all possible deceptions. This is our deception, and that is the only reality we have. And it's not just terrifying, it is also beautiful. And living within this mystery, being part of it, trying to unravel it, is the greatest adventure there is.